In the early stages of Math 123, what I just did may not settle well with some of the people coming in. It really is a stretch to be able to take the base 10 system, the one that we've come to count on this whole time, and to change up everything. A lot of people just hate that concept. So to kind of ease into this idea of converting from one base to another, a lot of times I'll just start counting until I hit 16. Obviously this is slower and you don't want them to depend on this method, but it's great for understanding the concepts. So if you find that the 2Ds aren't getting it, that last process, try this one instead. We're in the base 3 system. That means, well, okay, let's just represent 16 by counting down. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So I've just started from 0 and I've now represented 16 objects listing everything in between. And what I want to do is match them. Okay, 0, when I convert that to base 3, what does that look like? You just start counting from 0, from the bottom. So 0 matches, right? Then I would have 1. From here, I would have 2. Now notice this is a base 3 system. Since it's a base 3 system, what I have to keep in mind is that I cannot exceed 3 objects and represent it with 1 digit. In other words, right here at this point, we would normally go here, but remember, like in the base 10 system, we don't have one symbol to represent 10 objects. That's 2 different symbols, right? If we were in the base 11, the next thing we would use would be something like this, or base 12 and so forth. Those are all single symbols, but in base 10, since it's 10, we need to use 2. Well, the same thing is true in the base 3 system. We now need to use 2 symbols. So this one is not represented 3 that way, but more like 1 group of 3, 0 groups of 1, meaning this goes 0, 1, 2, 0, 1, 2, 0, 1, 2, and you're just going to keep repeating that process. They all go from 0 to 2. Once they hit 2, it goes back to 0 and the next one increases. So to represent 4, we would have this. 5 would look like this. Now remember, there is no 3 in the base 3 system, meaning I've gone through all of them. This guy goes back to 0, the next one increases by 1. And this doesn't seem to be as hard to understand. I mean, it's still really difficult, but a lot of people have an easier time understanding this concept where you just cycle 0, 1, 2, and then it goes back to 0 and the next one increases. So you just repeat that until you get to the digit you're looking for. Now, oh, see, now I've already made a mistake here. You cannot have a 3 in the base 3 system. So since I've gone from 0 to 1s to 2s, the next one over here would go, let's see here, it goes 0, 0, 1. That represents 9 in the base 3 system, which means I need to modify this guy too, right here. That would be 1, 0, 1, 1, 0, 2. Okay. 1, 1, 0. I'll just keep repeating the process till you get a little more familiar with it. Let's see, that one would be 1, 1, 2. The next one over would be 1, 2, 0. And the last one, sure enough, ends up being 1, 2, 1, which represents the same thing as 1 group of 3 squared plus 2 groups of 3 to the first plus 1 group of 3 to the 0. And all that I'm doing right here is I'm using the digit in the placeholder, which is a 1, drops down, and you begin with 0 here, so it's 3 to the 0, 3 to the first, 3 to the second. I have 1 group of 3 squared, and 2 groups of 3, and 1 group of 1, which if you were to simplify that, running out of room, but if you were to simplify that, you would have 1 times 9 plus 6 plus 1, which would give you, that's a 15, and 1, which does give you the 16.